Welcome back. Another Shoptalk episode for January 2026, and despite my best effort, there was quite a long time between this and the last video, and I apologize for that. But my horrible time management didn't allow me to do video work besides all the time critical customer work, so sorry for that. And I guess it's a little bit late for Happy New Year, but still, Happy New Year. Let's hope this one is not going to be a terrible one. And let's see what we have. I have a little bit of new tooling. I moved stuff around in a shop. I have a little bit of CNC milling. And Stefan points at old photos and old books. So let's have a go. I added a microscope to the lathe, and I want to show you the general setup of this. This is a about 80 euro digital camera microscope from Aliexpress. And I also purchased a mobile HDMI monitor. It's like 12 inches diagonal. Both can be powered via USB-C, just of a multi-port phone charger. And the signal from the camera to the monitor is HDMI. So there is no separate computer needed. So it's a very, very slim setup. There is no additional hardware needed. So let's have a look at this. When I set this up, I decided very early on that I wanted to be a semi-permanent setup. So I made a little bit of a bracket to hold this mobile screen on top of my DRO. So when I look at the stream from the camera, I also can have an eye on the DRO. And also touch-off tools, I can be right here looking at what's happening and be right here zeroing out the corresponding axis. So far that's working out quite well. The mounting of the monitor is just two simple 3D printed parts. It uses existing holes in the DRO, and the monitor has two threaded inserts up here, and it's just connected by a piece of 12mm pipe, and that's plenty stiff enough. I need to do a little bit work on cable management, but that's on the list for 2027, I guess. But yeah, up there, the monitor. Filming the monitor works quite bad. Got a little bit of flickering when the overhead light is on, but as you can see, it has a little bit of lag. It's terrible to do manual work under it, like deburring or something like that. That's still, for me, the realm of a optical microscope, where you where you actually look through a set of lenses and not a digital camera. This has a tiny bit of lag, and you have zero perception of depth with this compared to a stereo microscope. But for looking at machining processes where you have relatively defined motions, like a drill bit approaching a piece of work, it seems to work very well. Well, let's look at the camera. That's the camera, and it came with a supposedly 150x lens. Make of that what you will. The working distance of the lens is quite impressive. It's not a zoom lens, but it has it's manual focus. So you can go really, really, really close, like that close, and still focus, but you can be also like a meter away and still focus. So that's quite nice. For most what I do, I found something in the 100 to 150mm distance to be quite suitable with the resulting magnification on the screen. The camera can directly record to a micro SD card. It can take still images, and it also records, I think it records 1080p video or 4K. I have the camera currently on this parallelogram arm. It's mounted not to a lathe, because that would get very wobbly from slight machine vibrations. It's bad enough already with vibrations. So it's mounted to it's resting on behind the lathe on a part of the building. And that seems to work quite nicely. I also can get it very quickly out of the way if I'm doing something dirty where I don't want to have optics in the way. Also, when you do something like blowing off the work, well, add a lens cover. I need to 3D print or machine a little bit of a ring that goes in front of the lens and can hold a piece of glass to protect the lens from chips. But let's have a look how this looks in practice when I actually use it for machining. I have these parts that need 0.6 millimeter holes drilled into them, and it's quite nice to be able to see it without being hunched over the machine with magnifier. In the past, well, I still use this a lot. This is I think it's 7x magnification eye loop that a watchmaker would also use. And this is still my favorite way of looking very closely at stuff. You can get right in there, and it's just a great way, and it's just a very great way to look very close at things, and it's very inexpensive. And the quality of what you see is, of course, very, very good. But sometimes I don't want to hunch myself down at eye level on the lathe, so I'm going to try this out. you will when you see this disappear from the lathe again in coming videos, you will know that I started to hate it. There's our spot drill. Now we change to a 0.6 millimeter carbide drill. There it is, running at 3000 RPM, and I will plunge in about 0.3 millimeter increments. So the setup does not only show you the chip formation of your drilling process and gives you the information you need for a decision about your feed and packing depth, but it also shows you if your drill is on center line, both height and in the X direction, because you will see very easily if the drill deflects under magnification, and you can adjust accordingly. This is one use case that already is working out very well. I'm making these ring-shaped mirrors with a tapered, precision-finished surface on the inside, and the camera allows me to look inside there and monitor the cut without having to stick my face so close to the spinning chuck, which turns out is quite nice. This is semi-finishing the taper surface with a PKD diamond insert. The second tool for the surface is a diamond burnishing tool. This has a spring-loaded diamond sphere on the end, and you make a little bit of contact with the surface you want to burnish. Then you add some preload by advancing the machine slide. Then you move very slowly over the surface, and that burnishes away all the remaining surface topography. The problem is touching off the tool on the inside on this tapered surface is really, really hard to see. And I used to do this with a mirror, a magnifier, and a flashlight to see inside there. With the video microscope, I can very exactly see once the diamond makes contact with the surface, and that was exactly at this point. Now I can zero out the DRO, get my coolant nozzle in position, and run the burnishing process. And this is the actual diamond burnishing running under oil, so you see absolutely nothing. So this is the overview picture of what you see without magnification. You see this giant diamond burnishing tool stuck inside the aluminum part, and you barely see anything apart from flung away oil. So I suspect that the video microscope will be great help here in the future. And just to round it out, here a picture of the diamond burnished conical inside surface of the mirror. Found something on eBay that I absolutely needed to have, and it's a wooden box. Whoops. With something inside. So what we got here is a small indexing head for the surface grinder. Well, primarily for the surface grinder. These are made by a small company here in Germany called Dettinger, and they were kind enough to send me the manual for this, which mostly consists of how to calculate the angle for it. So thank you, Dettinger, because they didn't charge me any for the manual, which is very, very nice of them. So this is kind of grinding tools and grinding accessories have always this appeal of everything is hardened and ground to it, which makes it very, very nice. Every surface is ground, there's nothing milled. I checked the companies, they have their machine list, and they have all kinds of grinding equipment, surface grinders, IDOD grinders, and several more chick grinders, excuse me. And that explains how they make these. So this is a tilting indexing head or rotating spindle. The spindle runs in needle bearings apparently to the advertisement material. At some point I will take it apart to check if everything is in good condition, but not in this video. The teardown will be sometimes in the future. And what I found quite neat, it tilts up to 90 degrees, and normally this is set up like a sine bar. A normal sine bar doesn't work at 90 degrees. A sine bar works by knowing the distance of the two rollers, and you calculate your stack up of gauge blocks down here to get a certain angle. But above like 45 degrees, it really starts to fall apart. The angular error in relation to the error in the height stack gets rather large. And you can't go to 90 degrees for obvious reasons, because you can't get a gauge block stack. Well, you can't really. But what they did here is the sine bar is at an angle. One pivot of the sine bar arrangement is up here, and the other one is down here, so it's offset by 40 degrees. That means to get it to, if the rollers are horizontal, the spindle is only at 40 degrees. Then you add another 60 degrees, and you're at 90 degrees, but since it's offset, you easily can stack your gauge blocks underneath here. It makes it a little bit harder to calculate your gauge block stack, and the manual has the description how to calculate the gauge block stack. But yeah, that's a really, really clever arrangement, and it's super compact. It's very dense. There's a lot of gravity in it, but overall, it's really not very big, and it's a good match for my machines. They mentioned that it's not only for grinding, but you can also put this on a jig borer or a precision milling machine or wire EDM, RAM EDM measuring machines. I'm very certain that you can use this with a motor, running it with a belt for cylindrical grinding. But I guess the main purpose is with the indexing discs as an indexer. And the indexing pin is also kind of cool. It's this lever here, and there is a cam surface, and when you, as you can see, the pin cams over the surface and pulls or retracts the indexing pin that goes back to here. The indexing pin goes through the pivot axis back here, and it's a conical pin, and the bores in the indexing discs are also tapered, so that's a very positive fit. The indexing disc gets held in place with the collet nut. So it takes the same collet as my D-bit grinder and the milling machine, which is super convenient, also part of the reason why I bought it. So to not have another set of collets. So you can just undo it like this and index. And what I found quite neat is they have masking plates, because these indexing plates have a lot of holes, and often you need only like 4 indexes or 3 or 2 even. And this allows you to mask off all the other holes in the indexing disk. I think some of the super spacer indexes for milling machines also have this masking plate set up. Find that quite nifty. Another very clever piece of equipment that came with it is this. This is a sign bar attachment for the indexing spindle. So you put this on here, and these pins have a certain distance to each other. And by putting gauge blocks underneath them, this acts like a sign bar again. So you can do indexing that's not covered by the indexing plates. You put your gauge block stack under here, and then you have there's a wedge, and you add a little bit of a gauge block stack over here and this wedge to lock it in place. When you so it basically gets pressed on one gauge block stack. I haven't fully thought through it, but I think this works only with the spindle horizontal at 0 degrees, because it uses the base plate to index the sign bar attachment of. That's a very tight fit on here. So I wanted to show you how this looks on the milling machine, or on the surface grinder and the milling machine. I put it on the surface grinder up on the table, and currently I have it oriented in line with the spindle. So for example, if you would grind flats on the end of a piece of round stock, that would be the correct orientation. And as you can see, I'm even with the indexer butted up against the fence without spacing it off, I still have plenty of room for an extended workpiece out of the spindle. Like 50 millimeters travel. If I need more, of course I can hang the indexer off the back of the magnet a little bit and gain more. But there is a limit what you can do without a tailstock, of course. Also, when we tilt it upwards, with the spindle vertical, there's also like 40 millimeters between the collet and the grinding wheel. I think I have a little bit of travel in the vertical axis left, but for what I purchased this looks plenty. And it gets better if you tilt it a little bit like this. The main reason I bought this is for tool grinding. All the tool grinding I cannot do on the D-bit grinder is done on the surface grinder. And I used to use the punch grinding fixture that I have, and it works very well. But at times it's a bit clumsy when working with very small tools or very small parts. And that's why and due to the fact that this uses collets that go down to 0.5 millimeters in diameter, I think this will be a great match for what I do. For example, if I have to flute a tool, I can use this. I can put this also in line with the grinding spindle, like this. Tilt all the way down to 90 or to 0, or put it at an angle. So quite flexible, I think. Can't do spiral grinding with it, of course, but for any static tool grinding or simple rotary grinding, this will be a great addition. Pardon the mess in the CNC mill. It has run. I used it today and I haven't cleaned it yet. But as you can see, putting it here on the Lang 0-point system. I think this will work great for small indexing work on the CNC. I recently had a project where I needed to do a lot of 3-point indexing, and I used a very, very inexpensive 5C indexer, about the same size, but not very precise, to say it in kind words. Took a lot of finagling to make it work, and I think this will be superior to that. The underside of the indexer has a precision slot ground into it and 2 M6 threads. So it will be very easy to make an adapter plate that bolts on here and has the 4 pull studs for the Lang 0-point system. So that will be a little project that I have to make for myself, so I can use this on. So yeah, that's the small sine indexer. Quite a cool tool. Thought you might get a kick out of seeing this thing. When I take it, if I take it apart, I will film it. You might notice that you just need to look at my video scheduling. That's not because I was lazy. I'm lazy, but not that lazy. I'm just jam-packed with work, which is a good thing, but that makes taking video a little bit tough. But I try my best. So, so yeah, there's the indexing head. And let's see what else we have. Today we have another episode of Stefan Points at Old Photos. And I'm bringing to you the book Feinmechanik from Walter Mink and a Pfeiffer tooling catalog, which I'm not sure which year this came out. It only says number 14. Pfeiffer is kind of like Hoffman Tools today. It used to be a very large tooling vendor here in Germany. In 2018, they were consumed by Brüch and Ruger. So let's look at the tooling catalog first. What's interesting about them, they had showrooms for machines. The variety of machines in here is quite interesting. They had a pile of Weil lathes here, mills that looked like Kunstmann back here, some Ultimetal drill presses over here, a Fehlmann mill and drill machine from Switzerland, a bandsaw, a tool and cutter grinder, I think this is a Schütte, and over here a drill grinder. So quite the collection of machines, large bandsaw. Back here, this is probably a radial arm drill. They had a storefront where you could buy stuff in person. That's neat. Hoffmann used to have that, and I think they still have that. But yeah, there's just boxes of tools, and it's nice. Guessing by the machines on this picture, this catalog is from about 1970-ish. Why I wanted to show you this catalog is because there are, in modern tooling catalogs, you don't find all the cool stuff that made manual machines cool. You find CNC machine equipment today. So let's just have a look in here. And it's quite interesting. There is a lot more text than you have today in those catalogs, a lot more descriptions. For example, here, these are inserted drills, or U-drills, as some people call them. And there is really a lot of just information about why you should use it and what you could do with it. Like, you can not only drill, you could also bore with it and face and OD turn with it. And they will go into great detail about tools in this catalog. So I think for a hobbyist who is starting out and just wants to learn about what existed and what can be done and what tool can do what, get an old catalog and read through it. And just by seeing what exists, you will learn a lot. So this thing is quite neat. This is not forgotten by a long meme. This is a Valcut tree panning tool for drill press, milling machine, lathe. And you could use this to either cut very large holes or to cut out discs. Valcut is a Swiss company, and up until very recently, they still made them. The inventor Georg Wall passed away several years ago, and the company went under after that. I'm not 100% sure about the exact story how it happened, but it's quite a neat tool, and if I ever get my hands on them, I will buy it if one shows up on the used mark. And here they show how it works with the cutting edge behind the center of rotation, so it doesn't snag and explode in your face. Another tree panning or hole cutting tool is from GFS. That's a German company. GFS Werkzeuge Metallverarbeitung GmbH. They still make these to this day. They have very similar like hole cutters, but very dedicated tree panning tools with 2 blades and even with a integral steep taper shank like for the taper. What I found entertaining is that they still had planer tools like the gooseneck planer tools or normal planer tools in here. But also, if you look here, these are planer tools with the gooseneck, but with inserts, high-speed steel inserts. So there was some development in planer tools. And I mean, to this day, people use planers machining large structures. It's not entirely a thing of the past. I found this interesting. This is diamond turning. They go into the details of using the actual diamond, what you would use it for, and also how to set it up, because you would get a tiny diamond and you need to clamp it somehow with one of the shanks and use it to do mirror turning, for example, or on universal electric motors, the commutator where the brushes run on. That would be diamond turned in a lot of cases to give a very good surface finish. Here they show it even as an example. So these are monocrystalline diamonds, like a solid diamond, and these dia-compact tools, as they call them, these are polycrystalline diamonds. That's diamond that you take diamond dust and you sinter it into a solid. And that gives you the hardness of the diamond, but it's cheaper than taking an entire chunk of diamond. And here the work example is what I just described, turning down the commutator of a motor rotor. Also, CBN tools. You have 3 super cutting materials. You have MKD, which is monocrystalline diamond. You have PKD, that's polycrystalline diamond, and you have CBN, which is cubic boron nitride. All 3 are for different purposes. Monocrystalline diamond is for creating mirror surfaces in non-ferrous materials. Polycrystalline diamond is for machining non-ferrous metals, but it doesn't give you the super high surface finish as the monocrystalline diamond. And then you have CBN, which is for hardened tool steels, or hardened steels in general. And that's what this is. CBN for steels and cast steels above 45 HRC. Below 45 HRC, it's questionable to use CBN. There might be cases where it's advantage, but usually you want to use this in hardened steel. Over here, universal boring head. That's the Kuroda boring head, which is very similar to the Wohlhaupter boring head. I have an older video on one of these where I tear it down, and it's quite intriguing, but this catalog also has prices. So I had a UFB 3, and that was a 2,128 Deutsche Mark boring head at the time. Corrected for inflation, that's probably, I guess, 3,000 euro in today's money, I guess. I will put it on the screen down below. The Kuroda and Wohlhaupter boring heads had a very similar design philosophy, but there was also the or there still is, the D. Andrea boring heads. That's this style here with the hand crank. And these are marvelous. You can, while it's spinning, the hand crank part here stands still and you can move the slide for facing or for cutting ID, OD grooves with this crank while it's spinning. Or you have auto feeds, of course. And these are substantially more expensive. These are 5,200 Deutsche Mark in the smallest size and up to 12,000 Mark in the largest size. If you remember my endeavor in radius turning, I talked about this tool here, this double eccentric ball turning tool, and here it's in the catalog. It's the R25 and it's 2,100 Deutsche Mark. It's quite cool to see this in a large catalog. There was also motor-driven versions down here, but those are without a price. It's the you have to ask for the price kind of deal. Adjustable center for the tailstock to do taper turning, so you don't have to mess with the offset of your tailstock. But, well, this gives you a 25mm possible offset. These were made by Bowers. I have not seen one of these in person. I found this quite interesting. Let's zoom in a little bit. So if you're a CNC machinist today, you probably know these. These are like mill chucks. It's a mechanical, let's kind of call it chuck, but due to the nature of how it's built inside, it gives you tremendous holding force. And at the time, they were selling this as a quick change tooling option. So you would leave the mill chuck in your spindle, and you would have different straight shanked inserts. You could, of course, clamp end mills directly, or you could put in an arbor for shell mills, arbor for drill chuck, arbor with a taper sleeve so you can run like a Morse taper drill in it. Or they had an edge finder also with large cylindrical shank. Or over here they had an extension that would use smaller collets. So I found that quite interesting that they advertise this as a quick change tooling solution. That's kind of what I do on my decal milling machine with the hydraulic chuck. I often leave the hydraulic chuck in the spindle and I just use all similar straight shanked tooling in quick succession because it's a very precise and very quick way to change tools. That's also kind of vanished from today's tooling catalogs, all the grinding tooling, all the work holding for surface grinders, starting by just regular grinding vices. I have this one. That's made by Yam, which is a Japanese company. And it's really a nice high quality grinding vise. And at the time, this was like 600 German mark. All sorts of flavors of sine vices or adjustable vices, even multi-axis down here. That's kind of gone from today's catalogs. Same for indexing heads. The number of indexing heads in modern tooling catalogs, for obvious reasons, has gone to close to zero. So you had your Walter direct indexing head, you had a Walter kind of a CNC indexing head with a external controller. Rotary tables. And when you look at the prices, these are really, really expensive. Let's look here. A 250mm diameter rotary table without a 3-jaw chuck was 2,000 mark. Rotary table with a digital readout, tilting, indexing heads. These are made by Walter. Really quite the selection of indexing heads. These indexing heads were really expensive. An 80mm center height indexing head was 5,300 Deutsche Mark, which, well, that it's really a lot of money. So that's a magnetic chuck, like you would put on a lathe or a IDOD grinder. Normally you would mount it directly to the spindle, but they They also gave you the recommendation to just clamp the magnetic chuck in your 3-jar chuck and use it that way without having to swap chucks. Found that funny, because today we look at this and think, that's kind of janky, but no, it works. So Hermle is a well-known manufacturer of CNC mills and, back in the day, of toolroom mills. While the modern Hermle machines are amazing, and they are really, really good machines, no doubt about it, it's kind of a boring machine. This is way more fun to look at for me. It's the same layout as a like, for example, a Maho or Deckel toolroom mill, but in this case as a CNC already with a Heidenhain control. And they had a lot of options already. 3-axis simultaneous movement, spindles up to 10,000 RPM. The frame was cast iron and filled with epoxy granite for damping. Quite neat. What you would expect from a, at the time, very, very modern CNC mill. That's tooling catalog. Then I have this book, Walter Mink, Feinmechanik. Let's have a look at this. So I tried to translate the subtitle, a reference book for manufacturing by means of chip forming processes in the precision mechanic industry. And it was printed in 1954. So what did I want to show you there? There was one small chapter in the foreword about how to treat your workers and how to run a shop or a business. So there are 2 quotes that I wanted to read that I translated from German. The one is, experience has shown how valuable proposals from a forward-thinking and empathic workforce can be. So despite being in 1954, they already recognized that the workforce is not stupid. The worker gave good proposals for improvements to the higher-ups. And this book not only recognizes this, but also puts great emphasis on it. Also, they were thinking very highly of the skilled workforce. The second quote is, hardly any worker who is interested in the success of their work, and ultimately that's every worker, will close himself off to the necessity of such information. On the contrary, they will readily take every opportunity to broaden their professional knowledge, extending it into fields that just have been opened up by new developments. So they were really thinking very good about the workforce and how motivated the workers would be about learning new skills. And I found that quite interesting. That, I mean, 1954 is not exactly yesterday. That's quite some time ago. There was one chapter that I wanted to show in detail, and that is here. And it's about diamond turning, or as it's called here, Feinstbearbeitung, which is, let's see, machining by the finest of possibilities, if that makes any sense. So kind of a neat picture with a small pile of diamonds here. An actual diamond clamped in a tool holder. And then they have several examples of running production work with diamond tooling. It's mostly like cutting valve seats in carburetors and things like that, or cutting precision bronze bushings. And when I looked at these pictures, I noticed that the lathe that's used here for demonstrating the diamond turning it's the Bolli Feinstdrehbank, which is a ultra precision lathe, DW4. And this lathe is really a very different beast of what you know about lathes. Let's see if we have a... So it's more laid out like a cylindrical grinder than a lathe. And what I mean by that is, so here is a full view of the lathe. You have a very long table that's moving back and forth for your C-axis travel, and you have a short cross slide for facing. if you wanted to do taper turning on this lathe, you would not, there is no compound slide on this lathe because compound slides are stupid. What they did, they turned the entire table all the way up to 90 degrees so you could face with power feed. And you can also see that the ways on this machine, these are laid out like on a grinder. You have a V in the flat. So this entire machine is really built for ultra precision. The motor that drives the main spindle is not mounted to the frame of the machine, it's sitting next to the machine. The headstock is water cooled to prevent stromal growth. And overall, it's just an incredible machine. Quite a bit of line boring where the work would be mounted to the carriage and the diamond tool would rotate in the headstock of the machine. So to me, this is a mighty impressive, very specialized machine. They show up on the used market from time to time, but yeah, it's a very specialized machine and you would really buy this only if you had a need for it. Not like you're not turning down a PTO shaft for your tractor on this machine. Let's see if something else. Nope, that's all from this book that I want to show you. So Walter Mink, Feinmechanik, really good book, very, very, very good information in it. So have a look. They are out there. I think I have shown you these in the past. These are aluminum bezels or frames for a touch display that goes in some kind of a medical device. And I cut them out of 10mm cast aluminum plate. This is cast and fly cut plate that you can buy from every of the usual aluminum vendors. It's a wonderful material. It's super stable, doesn't move around despite the large material removal. This is like 80% of material removed. But this part has this very thin area here, which is only 1.5mm thick. Same on the other side. And when you grab this like that in a vise, these areas would start to vibrate. Very badly so. I tried it, and yeah, it will vibrate. Despite I'm finishing this with a 2mm cutter. But this would mess up the surface finish, which it's okay. It's a nice finish. It's smooth and it's even. The vibrations would mess that completely up, and it would very likely damage the cutter. So when it vibrates, it would just smack the end cutting face of the end mill. That's not very nice to a cutter, so we don't do it. So you could hold the stock, of course, in something like a vacuum chuck. Just suck it down and cut it. I don't have that option, so I'm using two self-centering vices with gripper jaws. The gripper jaws are quite nice. The way I use them is, well, most people, this is not my invention. I tighten them down really, really hard. Well, really hard, kind of hard. And the gripper jaws will imprint themselves into the stock. You can see the marks here. And this imprint is deep enough so it really registers with the teeth of the jaw. That allows me now, once it's imprinted or stamped, to grab the stock with very little torque. That's important. So the clamping force of the vise would make the stock either to bend upwards or downwards. It would cup from the clamping force. And the less force I can put into the stock, the less deflection I get. So I'm going only to put very little force into it. That's the clamping. The imprint, the stamping of the jaws, gives a mechanical connection. So you could now lift the entire machine with this with this plate, despite I torqued these to maybe 5 Newton meters just by hand. That's one part of the solution. The other solution is I need something to dampen these thin areas that really want to vibrate. And what I do is I take a piece of, this is rubber, 8mm thick rubber. I just bend it in a U shape. They put it between the vise body and the stock. Same on the back side. So that's the two areas where I'm cutting the thin section. Just bend it like this and put it in. It's very easy. Doesn't cost anything apart from a piece of rubber that I had. And that's all that's needed to really support these areas, dampen any vibrations out, and make it so I can machine it properly. So let's see how this goes. So this is roughing with a 6mm chip breaking end mill. So in the past I used a regular non-chip breaking end mill, and that created a huge pile of chips. So chip breaker it is, running at 22,000 RPM, feed of 2,000 millimeters per minute, and a step over of 1.5 millimeter. Maximum depth of cut is 10 millimeters. That's the thickness of the plate. And here you can see removing the bulk of the material in the areas that will later get this very thin floor section that I'm worried about. This is after roughing, and back here you can already see how thin the remaining stock is. There is still, I think, 100 microns of allowance in thickness for finishing. And you can also see the rubber spring, let's call it a spring in this case, supporting this area. And I changed the tool already to a 2mm 2-fluid finishing cutter. And you will see parts of it getting finished now. Finishing with the 2mm 2-fluid end mill, running at 22,000 RPM and a feed of 2,000 millimeters per minute. I left about 0.1 millimeter allowance for finishing, both on the sides and on the floor. And here I'm finishing the thin floor section without any trouble, without any vibration. And it's just beautiful. Takes its time, but the machine is running on its own, and I can do something else in the meantime. So I don't really lose much by running the CNC very much on the safe side. Chamfer end mill, this is spiral flute. Chamfer end mill, these run beautiful. Trying to hit everything that's possible with it, so manual deburr is not necessary. That's the entire first side of these parts done in one setup, and you will see in a second that the rubber springs did an excellent job at, yeah, you can see it here, at keeping these flats here free of chatter despite being very thin. The only thing that you have to consider is before you loosen the vise, you have to take out these rubber springs, otherwise the part will get yeeted up in the air and come back down and get dinged on when it hits the vices. So push these out. The nice thing about the rubber is it doesn't hurt when the end mill hits it. It just cuts through it and goes on. So this comes out. And as you can see, very little holding force required from the vise. Not really the scope of the video, but I think I can show you machining the back side of these display frames too. One has just been finished. And for the second side, I just made this fixture that has the exact inside dimensions of the display frame, and the display frame presses on here and bolts down with 4 screws. And it's programmed in a way that I just have to pick up the center bore and fixture to get my zero. These sidewalls also want to vibrate, but since the fit over the central puck here is quite tight, these sidebars here of the display frame are under tension. That's beneficial in this case to strengthen them against vibration. So I don't have any problems here that it wants to go into harmonics. Just using 4 M3 screws and large washers. When I use washers for something like this, I run the washers over the sanding plate to remove any of the stamping burr, just to make sure they don't leave any marks on the part. That's always very annoying if that happens. So that's ready to go. Change the tool. First tool is a 10mm 3-flute end mill. Knocking down the corners and then cutting the lip all around the part with 10mm 3-flute end mill. That's the 10mm 3-flute. Now we change to a 2mm because the part gets a O-ring groove all the way around. And that can be done with a 2mm end mill. Cutting the O-ring groove on the lip, just spiraling down very slowly. This is a long relieved 2mm end mill and I don't want to snap it. Okay, last tool is a 3mm chamfer end mill. The chamfering is a 2-step process because I also want to chamfer the holes or oblong holes. One might call them slots for the screws. So I'm adding 2 canned twist clamps and I remove the screws so I can reach in here with the chamfer mill. In a well-designed fixture, there would be separate clamps, like 2 little strap clamps that bolt in here once I remove the screws, instead of the can twist clamps. But I don't do good fixture design, so I'm relying on toolroom methods. That's another one of these frames finished. Comes with a little bit finagling off the fixture, just needs cleaning, and off to anodize. These get a proper professional anodize. A little jump forward in time, and here are the display frames all finished. Tiny bit of Scotch-Brite to it, just by hand with a Scotch-Brite pad, and washed them from all the cutting oil, and they come out really nice. I made really a lot of these over the years, and my process improved over the time, each time a little bit, and by now they come out of the machine ready to go without any need to touch them anymore. Most important thing that I want to show you was the little trick with the rubber spring protecting these thin wall sections from vibrating. Apparently, I have a funny medical condition that doesn't allow me to leave the way that my shop is organized longer intact than like 6 months. And this time it's this cabinet. In this spot, I had a drawer cabinet with like 5 large drawers. I will show you that in a second because that got a new purpose. I rebuilt it, I had new bearings in it, built a little bit of a riser, and used it to house all my mill accessories. But I had the issue that I didn't have a spot for the slotting head and the vertical head of the Decal FP1 if it's not in use. So I just stuffed it in a corner and covered it with a rag if necessary. But I didn't like that too much. So when a friend offered me one of these, they decommissioned them there at his day job and got it for a very reasonable price. I grabbed one of them because it's this flatbed style of drawers that can be readjusted in their height. So the lowest drawer has enough clearance to house both the slotting head and there is enough space next to it to have the vertical milling head if not in use. That's very convenient because I can just put them in here, move them in, close the door, and they are protected from dirt and out of sight, out of mind. And to get them back on the machine, that's very easy. Just put them over and crane them onto the machine without having to lift them very far by hand. So this was in really good condition. It just needed some cleaning and some outside paint. Also, I need to do something about the organizing in here because currently it's just all sitting in there without any structure. But this cabinet can really hold a lot of equipment on very small space. And most important, these large pieces of accessories like the slotting head. These are otherwise quite the pain to store. This is the drawer cabinet that got replaced by the flatbed one, and I moved it over here as a new stand for the D-bit grinder. You might remember that I built a little bit of a stand for the D-bit grinder out of 2 small Lista drawer units on a riser, but I figured I'm going to use this larger 5-drawer cabinet because this holds a ton more stuff, and I keep, for example, some of the grinding accessories for the surface grinder in it too, and the overflow of 40 taper tooling for the decal mill, and it's really a lot of stuff on a small footprint. And it's also very good height for the D-bit grinder. I have the flexible hose for the dust extraction hooked up right there. It's just ready to go. I have it at a 45-degree at the corner. In hindsight, I really missed having a D-bit grinder. I'm using this almost every day for tool grinding. It's a super important machine already, already and again. And I'm really happy to have it here. So yeah, that's the new old stand for D-bit grinder. That's all I got for today. Thanks for watching. Thanks for sticking around that long. And thanks for dealing with my horrible, irregular video upload schedule. And yeah, thanks for the support. It really means a lot. And all the kind comments that I get are really uplifting. My shop is... I do this for a living. I'm not a content creator for a living. I try to film as much as possible and I try to show you as much as possible, despite having a lot of secret squirrel work that I get more and more. But still, I try to show whatever I can if it's seemingly interesting. See you next time. Maybe share this video with friend or foe. Thank you all for watching. I'll be back.